Hey folks, a quick hint on this second problem in week 7. I've removed the questions here because I just want to focus on what it is you need to get going here. So what you have here is you have a product that can be staged in one of 4 cities: Atlanta, Lexington, Milwaukee, and Salt Lake City. And then what you have here are the unit shipping costs from Atlanta to Seattle, Atlanta to San Francisco, so on and so forth. And then what else you know here is that from Atlanta, I can ship 40,000 units, from Lexington, 35, so on and so forth. And then you have a demand in each one of these other, I think it's 11 cities that need this product. So the question is, how many units from each one of the hubs goes to each one of these cities? For example, Atlanta to Seattle, how many units do I need to ship from Atlanta? So the best way to get going on this is, if you see what I've done right below, is I've taken this matrix and I've recreated it, and I have, but instead of unit costs, what you effectively have now is all of these variables become your decision variables, meaning how many units get shipped from Atlanta to Seattle, how many from Milwaukee to Fayetteville, so on and so forth. So that would be the first thing that I would do here, is I would recreate this matrix down here, realizing that these become your decision variables for each one of the combinations of hub to outlying cities, if you want to say that. So remember now that what you want to do is you want to minimize the cost, right? And so the cost here in the objective function, what you're going to have is you're going to have unit costs times unit shipped. So for example, if you wanted to use R30 as your cell where you're computing your objective function, that would be the sum product of the costs times the units that are shipped. Then it's very simple from there. You have 2 constraints. The total number of units shipped from Atlanta has to be less than or equal to 40,000. So I might go in here and compute the total number of units that are being shipped from Atlanta. And then so that the maximum number of units here becomes one of the constraints. So you have Atlanta less than or equal to 40,000, Lexington less than or equal to 35,000, so on and so forth. So you can put that all in as one constraint. The other constraint is that the demand that you are required to ship to each one of these cities. So you might go in here and create a cell that equals the sum of these values. Actually, you know what? I might have already done that. Hold on, let me see what I had here. Let me get rid of this row since I'm doing it below. So that's the total demand that's required. So let's see, ship to, and then go in here and just say this is equal to the sum of the total number of units shipped to Seattle. And then if you take that and you copy it all the way across, right, what you're going to be computing is the number of units shipped to Seattle, San Francisco, so on and so forth. Then the final constraint is that these values must be equal to these values. And because you're minimizing this, I wouldn't ship any more than I needed to. So again, these values equal to these set values for the requirement. So one more time here, new matrix for decision variables. So when you go into solver, these would be your decision variables. Then very simple, you have 2 constraints. The total number of units shipped from Atlanta, Lexington, Milwaukee, Salt Lake City, respectively, has to be less than or equal to the right-hand side here. So just compute the total number that's being shipped, then go into solver, and you can add that as one constraint as you have been doing. And then you have to compute the total number of units that are being shipped to each city and make sure that you meet the demand. And I would set this equal to these values. This constraint is less than or equal to, this constraint is equal to. So that should get you going. The only other thing, make sure you add in a function here or an equation here to compute your objective function, and obviously that wants to be minimized. Once you do that, solve the model. If you do it right, it should come out to the total cost, I believe, is $56,335. Then run the sensitivity analysis only one time and answer all the questions. So that should get you going. If there's more questions, let's post them here on the board, and we'll get everybody squared away. Thanks.